Greetings from Delhi Skill and Entrepreneurship University, Oakland campus. Minds Explorer. We are a team of 10 dedicated engineers working on the next-gen space technology rover for ISRO Robotics Challenge 2024.
This is Syam Sundar. To have a comprehensive control and command on this rover, we have developed a control room where here we have 4 screens, 2 our sensor screen and 2 of our live footage of the camera. One is ESP camera and one is depth camera. Here we can see the first screen of this control room. Here we can see different sensors data, current sensor, voltage sensor, signal strength, rover speed, etc. In the second screen is a terminal unit. Overall called. Here we can see the graphical representation of current and power uses and battery voltage. Wi-Fi received signal strength also we can see here, and this is continuously changing by the time. Here you can see this. Now we are going to give a dub command to our robotic arm. You can see here, and the operation is performing. Here to control our camera, we have this control panel from which we can control our camera. We can stop the camera and then again start our camera. And we can control different parameters.
Third screen comprises of depth camera stream with an ability of using AI algorithm for crater identification and obstacle detection. This stream will give us two type of visual data. One is the RGB image and another is the depth field of view. The depth view will provide us pixel distance and its location data. This data will then be used in ROS to create map of terrain and locate the rover within it. In this video, the rover is doing crater avoidance using depth camera stream, where there are two streams. One is the RGB stream and another is the depth stream using IR sensor. Using this stream, the rover can do effective path planning and crater avoidance in real time. So the robot has traveled more than 1.5 meters by avoiding the crater. The AI algorithm is capable of detecting the craters both in highlight and low light conditions. Screen 4 features of point cloud map from the depth camera. This point cloud map is generated inside the ROS environment. This will map the pixel around its surrounding and its distance from the center. This will give us the insight where the rover is located on the terrain and where we have to go. This will be used in navigation in manual mode as well as in autonomous mode. An additional screen 5 is built to view the navigation to camera, which is a small cam facing downwards towards the ground. The purpose of this data stream is to bring back the footage of the robotic arm picking operation as well as the detection of sample tube and sample container in real time. In case if manual option has to be exercised, then we must know where the tube is located and where we have to pick it from.
We have provided the emergency button to stop the power from battery to actuators in case of emergency.
Our emergency kill switch design is a very sophisticated design where we have focused more on cutting the power from its actuator rather than shutting down the entire computer system of the rover. For practical implication of this design, we are using two contacts. One is the NC contact and another is NO contact. NC will be responsible for cutting down the power from its actuator, rover actuators, and NO contact will provide the alarm trigger signal.
The purpose of this optimization is to ensure that we meet the requirements of qualification 1 and 2 in minimum power consumption, at minimum weight and in an economical budget. Currently, our team is working in the upgradation of the arena to 4 into 10 meters as specified in the Walls book. Secondly, we are meticulously testing each and every hardware and software block so that when assembled together, they will perform exceptionally well in qualification work in a fully autonomous mode.